Hello, my name is Knecht, and this is my recorded video abstract. The title of my project is How Climate Change Has Affected Flooding in Wisconsin. I'll begin by reading the abstract of my project. Climate change has affected the world in many ways. Studies show that flooding has been changing due to climate change, though its effects in Wisconsin remain uninvestigated. The study was conducted utilizing data gathered from the USGS water data website, along with data munging skills in Microsoft Excel and mapping skills in ArcGIS Pro. Two bar graphs and a map of the watersheds investigated in Wisconsin were created to show the changes in flooding and its effects across the state. The results came from analyzing averages of the 2.33-year annual flood levels from the past 80 years. The 80 years of data were split between two 40-year periods that display the changes that occurred over time due to climate change. The state of Wisconsin was observed as 5 distinct physiographic regions, so as to spatially differentiate the data and see how changes were dispersed across the state. The results revealed that change was occurring differently throughout the state, though mainly illustrated that very little change was occurring in the northern regions of the state, while flood levels were increasing in the southern regions of the state. Overall, the state has been experiencing a rise in flood levels, so far by around 100 CFS annually. These results imply that climate change is causing a rise in flooding throughout the state and may continue to do so as it worsens. Many aspects of Wisconsin's present, past, and future are affected by its many rivers and lakes. Knowing how these changes are occurring and may continue to occur can help in planning prepare Wisconsin for the future. My research objective for this project pertained to observing how Wisconsin flood trends have changed over time alongside climate change. I did so by extracting flood records dating back to 1940 and analyzing them to ascertain what types of changes have been occurring due to climate change. After this, I made inferences from the conclusions I drew in order to discuss the implications this data holds for Wisconsin's future. I started out by characterizing the 5 physiographic regions as laid out by Loyal Durand in 1933. These 5 regions, as we learned about during the semester, are the Lake Superior lowlands, Northern highlands, Central plains, Western uplands, and Eastern ridges and lowlands. I then gathered flood records from the USGS water data website, which collects records on stream gauges from streams all across the US. I selected 2 stream gauges per region so as to disperse the data more. I collected records dating back to 1940, by which I split these records into 2 periods. Period 1 is 1940 through 1979, and period 2 is 1980 through 2019. I chose this split because 1980 is when climate change began to increase much more dramatically. The records from period 1 show the trends before the change, and the records from period 2 show the trends after the change, allowing me to compare the changes over time in lieu of climate change. I gathered data on the discharge or stream flow of these streams in cubic feet per second, or CFS, as they pertain to the 2.33-year annual flood. This flood illustrates the frequency and magnitude of floods over time, as it is the most recurrent flood with a recurrence interval of 2.33 years. After gathering the data, I imported it all into Excel, where I could clean up and analyze the data, creating 2 bar charts that display the results. I also utilized ArcGIS Pro to map out each watershed I was collecting data from, utilizing the watershed tool that the program possesses. I did so in order to portray the sizes and locations of each watershed. This is the map of the physiographic regions created by Loyal Durand in 1933. You can see the Lake Superior lowlands at the top, the Northern highlands, the Central plains in the middle, the Western uplands, as well as the Eastern ridges and lowlands. The first resulting item was the map that I created. It shows the sizes and locations of all 10 watersheds that I collected data from. Then, there are the 2 bar charts that I created from the munged data in Excel. The first chart displays the averages of each watershed for each period. The second chart displays the total averages for the whole state for both periods, so as to see what overall change has occurred in Wisconsin. Here is the map displaying the sizes and locations of each watershed. They are categorized by size in square kilometers, with the actual stream gauge location marked by the blue pins. Next, we have the first bar chart. The bars represent the periods, blue being period 1 and orange being period 2. The discharge values are displayed in CFS on the y-axis, while the stream gauge numbers in their respective physiographic regions are displayed on the x-axis. You can see uneven changes across the different watersheds, with the southern two regions displaying rises in discharge between the two periods, and the northern three regions displaying little to no change. Lastly, we have the second bar chart. This chart displays the total overall change for the state. You can see that there has been an increase in discharge of around 100 CFS annually between the periods. This has significant implications for the future. So as we have seen, there are indeed flooding changes in Wisconsin due to climate change. These changes are not uniform across the state. We are seeing greater increases of flooding in the southern two regions, as well as some minor increases in the Lake Superior lowlands. The Central Plains and Northern Highlands have experienced little to no change, with one watershed in the Northern Highlands showing a decrease in discharge values between the two periods. There are many contributing factors to these differences. Two major factors are the precipitation and topography of the state. Precipitation is a major control of flooding and is a driving factor for changes in flooding. Lake effect is a major precipitation pattern in Wisconsin and can be attributed to the rises seen in the eastern ridges and lowlands along Lake Michigan and in the Lake Superior lowlands along Lake Superior. The largest contributing factor for the state of Wisconsin to flood trend differences across the state is topography. Topography is another major control of flooding, in which steeper topography feeds water into streams faster than flatter terrain. The Lake Superior lowlands, western uplands, and eastern ridges and lowlands all possess the areas of greatest steepness and terrain differences in the state. This makes sense when compared to the results of the study in that these areas are experiencing the greatest change between the periods and are seeing increases between them. The Northern Highlands and Central Plains possess the flattest terrain in the state, and so it makes sense that they are not seeing much change between the two periods, with one watershed even seeing a decrease between them. These findings indicate that anyone living near rivers and streams in the three physiographic regions that are seeing increases in discharge measurements should begin to look to the future in preparing for changing flood patterns. These changes can mean very bad things for people living in the areas affected by them. The land they call home can be destroyed by rising floods, and they will be forced to move. Likewise, if that decrease is seen in northern highlands continues, the land there may also be destroyed by a lack of water. Infrastructure and ways of life will all be forced to move and change if these trends continue on the path they are currently on. Future studies should focus on ways to combat climate change. They should investigate new, healthier, and greener ways of living so that everyone can do their part in helping the planet. A major field for these kinds of changes is in clean and renewable energy, such as wind, hydro, geothermal, and nuclear energies. A clean and healthy future is possible if everyone makes the necessary sacrifices in order to make it happen. These are the references I utilized for the project. I'd like to thank the Department of Geography and Anthropology for providing me with all the skills and knowledge necessary for completing this project. Hans Kischel is the department librarian and a godsend when it comes to acquiring the necessary literature for projects like this. Next, I'd like to thank Dr. Faulkner and Dr. Running for their aid in a similar project by which I attributed knowledge and skills I gained to this project. Similarly, I'd like to thank Dr. Hafner for his aid on another project related to this one. And lastly, I'd like to thank Dr. Zeitler for his exceptional teaching this semester and for providing me with the source of the physiographic regions map that I utilized. Thank you.